Good day, this is Jubelle Ross, and in this video we are talking about Wilson's theorem. But before we start, at the end of this video we are expecting to first is define Wilson's theorem. Second, discuss the mathematicians have contributed to Wilson's theorem. And lastly, solve problems regarding this theorem. So, let's start. What is Wilson's theorem? According to Britannica, Wilson's theorem in number theory, theorem that any prime p divides p minus 1 factorial plus 1, where n is a factorial notation for 1 times 2 times 3 times 4 times n. For example, 5 divides p minus 1 factorial plus 1 is equal to 4 factorial plus 1 is equal to 25. The conjecture was first published by English mathematician Edward Waring in 1770 Thoughts on Algebra, where he ascribed it to the English mathematician John Wilson. The theorem was proved by French mathematician Joseph Louis Lagrange in 1771. The converse of the theorem is also true. That is, n minus 1 factorial plus 1 is not divisible by a composite number n. In the theory, these theorems provide on a test for primes. In practice, the calculations are impractical for large number. And now, let's move on to the mathematicians behind this theorem. An English mathematician is best known for Wilson's theorem. If p is prime, then 1 plus p minus 1 factorial is divisible by p. John Wilson was an English mathematician. Wilson's theorem is named after him. Wilson attended school in Starvey, Cumbria, before going up to Peterhouse, Cambridge in 1757, where he was a student of Edward Waring. He was a senior wrangler in 1761. He was later knighted and became a Fellow of Royal Society in 1782. He was a judge of common pleas from 1786 until his death 1793. And finally, we will now solve problems regarding this theorem. And for the problem number 1, what is the remainder of 43 factorial modulo 47? Let us first our formula, which is p minus 1 factorial is equal to negative 1 modulo p. Now, let's substitute our prime, which is the 47. Now, 47 minus 1 factorial is equal to negative 1 modulo 47. Since we subtract the 47 minus 1, it will become 46 factorial is equal to negative 1 modulo 47. Since we are looking for the 43 factorial, then it will become 46 times 45 times 44 times 43 factorial is equal to negative 1 modulo 47. Now, we need to eradicate this 46 times 45 times 44. To do that, we will subtract it from our prime, which is 47. So, 46 minus 47 will become negative 1. 45 minus 47 will become negative 2. 44 minus 47 will become negative 3. So, we have now negative 1 times negative 2 times negative 3 times 43 factorial is equal to negative 1 modulo 47. Since we have negative 1 from the both side, we will divide it to negative 1 and it will become positive 1. Now, the negative 2 times the negative 3 will become 6. So, we have 6 times 43 factorial is equal to positive 1 modulo 47. Now, we need to eradicate the 6 in the other side. To do that, our positive 1 plus to our prime number, which is 47, will become 48. So we have now 6 times 43 factorial is equal to 48 modulo 47. To do to eradicate the 6 in the other side, we will now divide it in 48. So finally, we get our remainder, which is 8. So we have our solution, which is 43 factorial is equal to 8 modulo 47. And now, let's move on to our second example, which is getting the remainder of 94 factorial modulo 47. Like we did in our first example, write first our formula, which is p minus 1 factorial is equal to negative 1 modulo p. Substitute. So it will become 97 minus 1 factorial is equal to negative 1 modulo 47. So, since we are looking for 94 factorial, it will become 96 times 95 times 94 factorial is equal to negative 1 modulo 97. So, like we did in our first example, our 96 minus 2r prime, which will become negative 1, and 95 minus 2r prime 97, it will become negative 2. So, we have here negative 1 times negative 2 times 94 factorial is equal to negative 1 modulo 47. Let's multiply our both negative numbers, which is negative 1 times negative 2. So we will have positive 2 times 94 factorial is equal to negative 1 modulo 47. So our negative 1 from the other side, we will add it to our prime like we did in our first example. So it will become 96 because negative 1 plus 97 will become negative 6. Then divide it to our 2 in the other side. So we have 94 factorial is equal to 96 divided 2 is 48 modulo 97. So that's our final answer. Actually, we have other ways to get our answer in here in this problem. That is p minus 1 divide 2. So our p is 97 minus 1 will become 96. Divide 2 is 48. So as you can see, we get the same answer. But that is not applicable to all problem. So that's all in this video. I hope you learned something, and thank you for watching.